Thank you for introduction. Assalamu alaikum, dear colleagues. Good morning, good day, dear colleagues, friends. It's a big pleasure for me to present our research work in this ADIPEC. So, could someone help to put presentation on the computer, on the screen? Okay. So we all know that this traditional way to recover the oil, primary first, then secondary, then tertiary. So tertiary we call EOR, enhanced oil recovery, and it's divided into 4 or 5 main directions. Salam alaikum, Dr. Shehadeh. So thermal is the most widely used EOR and most early EORs, and now it's have about 80 to 85% of total EOR, and it is efficient, but it has many limitations like impermeable barrier, thermal loss should be less, the depth of the well should be not too high because of thermal loss of heat and so on. So and gas flooding is mainly related it should have a source of the gas, for example, CO2, most widely used EOR, most efficient EOR, but it should have enough CO2 volumes and pipelines and infrastructure and so on, so it will cost money. And it is the second EOR in terms of application volumes. And microbiological and other methods is under R&D stage, and now EOR it have only 3 to 5% of total EOR techniques applied in the world. So, but it have not have this limitation like thermal and gas flooding, and that's just we think that EOR based on chemicals, mainly on polymers, have a bright future, especially considering last recent experience in America, in Canada, Milne Point, and so on. So if we look for the world experience, it expanded widely all over metrics and all over many countries, including Middle East. In most remarkable results we can see from PDO, Marmol oil field, Nimeri oil field, and so on. So they're applying polymer flood in wide range, in full field scale, and they achieved very remarkable results. So, and Uzen field is very old field in Kazakhstan, in western Kazakhstan, discovered in 1960s and put in stream in this same year, and it have a multi-layer reservoir with a high heterogeneity, compatibility, layering, paraffin, viscosity about 3 to 5 centipoise, moderate temperature, and it's developed using secondary method, water flooding. So because of high permeability sieve zones, water has breakthrough from injection to production site and causes many troubles. Now it experienced in 92, 93 water cut and producing a lot of water. And we're using many techniques, standard traditional techniques like infill drilling, hydraulic fracturing, acidizing, and so on, but it not helps to improve recovery. It only helps to decrease the gap between the declining. So we're trying to save the oil rates, but it's very tough. It have high cost, and we couldn't decrease the water cut, the main issue of the problem of during oil recovery. So if you can look at the production history, I would like focus on this figure, right figure. We can see that depletion of recoverable resource, which means the ratio of recoverable resource in percentage, and we recovered about 80% of recoverable reserves, and now water cut is more than 90%, which shows very clearly that it's non-uniform recover, and we have a lot of oil down in subsurface, which can be produced through the EOR. So we, based on world experience, we make a simple graph, putting in radar chart, putting the highest conditions where polymer flood have application worldwide. It's the real applications, and the minimum one, and we put in a green circle, green lines within condition. We can see it have a favorable conditions, but the main problems is moderate temperature, and salinity of the reservoir. So it's main challenges. However, we see the analogs. So what we focus during literature review, we focus on analogs, where instead of doing simulations, laboratory, some mechanistic studies, we prefer to look for analogs for real field applications, because as an industry guy, I believe in real outcomes from the field. And real field outcomes, like China, Uzen Oil Field is most famous polymer flood in the world, is the biggest polymer flood in the world. They have 15,000 injectors, 11,000 of polymer flood, 4,000 of alkaline surfactant polymer injecting in a daily basis for many decades. So, and it contributes to 1/3 of total oil production in Uzen Oil Field, which situated in Heilongjiang, in East China. And second analogs is a Mangala field in India. They also have remarkable results. They have full field scale polymer flood implementation, and we look for these fields, and especially we're looking for the problems which they faced in order to not repeat these problems what they faced previously. Also, we did TNA analysis, total asset number, because if polymer flood have a perspective, which means it have perspective for other techniques, modified polymer floods like surfactant polymer flood, alkaline surfactant polymer flood, or alkaline polymer flood, and so on. So, and TNA is a very important value in this investigation, because if you inject alkaline, you will generate in situ soap and improve your decreasing of interfacial tension. So we put on the table the values from India fields, from Omanian fields, and put Uzen Oil Field, and put between them Kazakhstani oil fields. And we see that Uzen Field don't have a highest TNA number. In contrast, other fields in same region have a higher TNA number, which means these fields more perspective than Uzen Field if we want to apply ASP flooding. However, Uzen Oil Field have a very low TNA number, but they have very big success in Uzen Oil Field. So, which means it still can be considered, but instead of ISP, polymer flood have a more perspective in terms of feasibility, in terms of economics, in terms of many other aspects. So what we first do in our investigation, we did chemical analysis of the all available water sources, because water source is the first important aspect of success of polymer flood. If you fail with water, your project overall will be failed. So Uzen Field have three water sources: Cretaceous brine, which is used for reservoir pressure maintenance system. It's produced through the dedicated production water wells. Caspian Sea water, which is transferred from Caspian Sea far from 150 kilometers, and it was used as a first injectant during first stage of development, and produced brine. So Caspian Sea water have a moderate salinity. It's not same story as Middle East. I just swim yesterday in your sea. It is very saline. I guess it have more than 100, maybe 200 grams per liter, but in our case it's very low. It's only 14 grams per liter. And Cretaceous brine have a lower salinity, and produced water has a highest salinity, about 60 grams per liter. But initially it was about 150 grams per liter. Because of injecting 60 years of this Caspian Sea water, the salinity was decreased more than 2 times. And main point here is looking for dissolved oxygen. So produced water have a high oxygen, and Caspian seawater has a extremely high oxygen levels, which will degrade the polymer. And produced water have a high content of TSS and oil, residual oil content. Thus we selected as the best options as a Cretaceous brine. And also based on peer review process, which has been, we have feedback from the moderators of this session. They asked us to do risk matrix of water sources. And finally, we choose a Cretaceous brine based on these risks and availability. Next, we look for Indian Mangala field experience and found that at the initial stage they injected 3630S polymer, which is standard copolymer without ATBS monomers. And because of moderate temperature, it have increased hydrolysis degree, and polymer have a thermal degradation after 60, 90 days, and expected viscosity decreases 2 times, and thus it has been produced more early than expected in production site and caused many problems in production site. Thus, they injected about 6 years of flow pump 3630s and found that they should change to ATBS polymers, and they start to inject ATBS polymers like 5205, 5215 since 2020, and they get better results. Just we said, okay, it's very similar condition. Let's start just directly with ATBS. Don't repeat the problems which faced during the Mangala field. Okay, 4 minutes. Okay, and we also it's not a decision not made only by ourselves. We also have a friends like Randy Seawright, Antoine Thomas, and we asked their opinion, and we considered the opinion and selected. We focused on ATBS polymers and did retention tests and found that ATBS polymers have less retention than the standard polymers. Then we go to geological and petrophysical screening and found that there is a big 3 reservoir complexes, and we found that lower depths have a better condition to implement because of lower temperature. And we have many of perspective pilot zones to implement polymer flood, and found 14-9, which is have a good well pattern. Facies have high permeability and available of Cretaceous brine. And based on simulation, we found offset producers, and based on simulation, we found our target viscosity, which means in situ condition should be 15, and at low shear rate, it should have this concentration of 1426 ppm, and we converted to the standard condition 7.36 reciprocal second and 25C. We found it should be at the surface about 25 centipoise, and we put in the polymer flood injection program, considering the active content and so on, and right numbers of the badges every day, 22 badges. So we rounded the number from 1426 to 16 milligrams per liter. And finally, we did feasibility studies, forecast, and forecast is based not on simulation, based on economics. How much oil we need to produce to make this pilot viable, and other will be just, so pilot will be like a simulation. So, and also we have a standard polymer flood surveillance program, and finally all these decisions starting from literature review, from screening to selecting the polymers, to select the concentration polymer flood injection program, surveillance program, water cut measurements, and all this stuff is concisely integrated in the book called Polymer EOR Pilot Project Passport, which serves as a guideline for the entire polymer flood pilot. So finally, I would like to say that we recently organized an EOR seminar in Kazakhstan, and we would like to do it in 2027 in May. I would like to welcome all of EOR guys to be here. And I know that I don't have any more time to questions. For more detailed aspects of discussion, we got recently a podcast with Randy, with Antoine. I know it's very long, about 2 hours. Please be patient, and I encourage all of you to listen to us and our discussions. Thank you. Ah? Okay. Could you close? Yeah, yeah, it's okay. Just put it closer. Yeah. Xinjiang. Yeah. Yeah, it's very good question because still, if we implemented Polymer Flood over 60 years and still we don't have a common idea on how to select the polymers. There is a different approaches to select the polymer. As you said in Daching, the first time in 1996 they used base case design developed by Rendi, Seawright, and Sorby, which means mobility ratio should be multiplied by heterogeneity or permeability contrast. So you have a mobility ratio of 10 and permeability contrast 4. You multiply it, become 40, and you inject the 40 centipoise. Then you, as you are a pioneer in this direction, you try to move forward and inject it even 300, 400 centipoise. In this case, we did simulations which incorporate all this mobility ratio, all heterogeneity based on the, how to say, history matched simulation modeling, and found that when you increase the viscosity in situ, you will decrease your oil income, oil output. But after 15 centipoise, it's like a shallow, how it calls in English, I forgot. It's not increasing still, but not. It's very clear that showing that your money will not getting back after 15 centipoise. And it's in line, we also did calculation based on mobility ratio. It's in line with mobility ratio calculations. In Uzen Field, mobility ratio about, endpoint mobility ratio about 3, and permeability contrast between 3 and 5. And it's have a good correlation. That's why we confident that 15 centipoise will be a good option at the first time. As I said, we're doing pilot like a simulation. We will see what will be results. If it will not be enough, we can increase. If we can decrease, we will do tuning during the pilot. Thank you.